right, the first 4, it told you that they varied inversely. So you knew you were using the y equals a over x inverse variation. Okay, so got that. Anytime it says inversely, you know that's division. So you've got that in the corner of your mind. Now it says after that, it says use the given values to write an equation relating x and y, then find x equals 2. So you got 2 points on this one. An equation and then solve when x equals 2. So number 1, your y is 29. Don't know my a yet. The x is -1. Okay, solve this for a. It's being divided by -1, so you multiply by -1, and your a would be -29. So my first answer now is to write that with the y and the x. Y would equal -29 over x. There's 1 point. Okay, now I get another point by solving for y when x equals 2. So -29 divided by 2. I just left my answer that way. If you, what would that be, 14 halves?
Yeah.
So if you put that, that's 14 and a half, that's okay as well. But you had to have the equation and solve it for when y or when x is 2. Got to have those 2 things on all 4 of them.
Can you multiply by -1?
On that one, yes, because it was being divided by -1. Now number 2, my y is 11 and my x is 8. So my a is being divided by 8. I would multiply by 8. Gets me an a of 88. So my first answer for number 2 would be y equals 88 over x. My second answer, plug a 2 in for the x. This one, it actually comes out to a whole number, gets you 44. So you had to have those 2 answers for number 2. Okay, on number 3, my y is 12 and my x is 3. So my a is being divided by 3. I multiply by 3 and get 36. So my first answer would be y equals a divided by, I'm about to screw that up, 36 is my a. So 36 divided by x. Let me just mark that out. 36 divided by x. That still didn't look good. Last try. Okay, now there's my first answer. When I plug a 2 in, 36 divided by 2 gets me 18. So there's my 2 answers for number 3. All right, number 4 is the one that they put the fractions on, so it could have got a little bit tricky how you wrote your equation. Several different ways you could write it. I got what you need on that page? I'll go to a new one for number 4. Still got the y equals a over x because it's inverse still. My y is 7/6 and my x is 3/7. So my a is being divided by 3/7, so I'm going to undo that by multiplying by 3/7. So my a is going to be whatever 7/6 times 3/7 is. Is that right? 7 times 3, 6 times 7. So then that reduces, right? What's that the same as? Yeah, so my a is a half. But when I write that as a division, you're not going to write 1/2 divided by x, because that, if we wrote it like that, that's like in a complex fraction, you know. So we're not gonna write it like that. What I did, and you could write it several different ways. I just wrote the y equals the 1 like that.
Did you say 0.5 over x?
You could do that. 0.5 over x is fine as well. Okay, so there's my first part. Now when I plug the 2 in, that's just 1 over 2 times 2, so you get 1/4.
So you wouldn't multiply the reciprocal, like 7, 6 times 7 times, to get rid of it?
No. Because I get why you think that, because it's division. But we're not doing the division, we're undoing the division. Like, it's being divided by 2, so you multiply by 2. Same concept. Being divided by 3/7, so you multiply by 3/7. Alright. 5 through 8 are tricky but easy. like that, don't you? Everybody got what you need on that page? So
No.
I forgot to put stuff on that video. Alright, first thing you needed to remember, just the normal, if I graph just the parent function here, it would look something like that, right? So what we're supposed to describe for 5, 6, 7, and 8 is how do those move from that. And we've had questions like that on every test, but this time they're generalizing it a lot more. They're just like asking you to say, does it got to be positive or negative kind of thing. Okay? So on number 5, what I notice about that takes this graph on number 5 and it scoots it to the right and up. True? Alright, so on this thing, the right, left and right is down here with the H. It is the H. It's down here with the X. And this is where it's a little bit tricky. To go right and left, it's always the opposite way. So we're thinking right, we need to make it a negative. But no, because they already have the negative there. So if we made our H be a negative, minus a negative would turn it to a positive. We want it to stay that negative. So our H would need to be a positive. Bless you.
So it's actually on this, it's going to be the same, like right, positive, left, negative.
Because they've already got the negative there, yes. The up and down is what it is. So we scooted it up, that is positive. Okay, on number 6, it scooted it right. So we've already established when it scoots it right, we're that. But it didn't go up or down any. So to not go up or down, we wouldn't want to add or subtract anything. So our K would be 0. Now 7 bothered some people because it looks like there may be a reflection or something in that, but that's all irrelevant. We still, just the 2 basic curves go left and then up. So if it goes left on number 7, our H would be negative, and then up is positive.
Wait, how do you know?
Well, because it would originally be right there approaching the axis, but now on number 7, it's scooted, this is over here, it's scooted like that. So it's moved it. Alright, on 8, it didn't go right or left any. It's both still approaching the y-axis, so the H doesn't change. So on number 8, the H would be 0, but it does go way up. So the K would be positive.
I like that so much better than having to tell like exactly.
Yeah. Alright, so down to 9 now, which that's where 9 was kind of just like the bell ringer. Alright. Number 9, it's a division, so I'm going to keep change flip. So I'll have 6a squared over b times 5b squared over 3a to the 4th. Okay, I'll do this one how most of y'all do them. I'll just multiply straight across the top. 6 times 5 is 30. And then you've got an a squared times a b squared. Straight across the bottom, I just got a 3, an a to the 4th, and a b. Okay, so now you're 30 over 3, that's 10. A squared over a to the 4th. Huh? Yeah, but what do we do when we divide fractions? Multiply the reciprocal. So I got a squared over a to the fourth. What does that do for me? A squared on the bottom. And then I got b squared over b. What does that reduce to? Just b on the top. Good job. Okay. Addition and subtraction is where you got to get the common denominator. So number 10 is subtraction. So that's what we're looking at on it. Back on what you need on 9. Alright. I got t squared. What? I'm sorry, Gracie. Here you go. You're welcome. Bless you. Alright, so back on 10 again. We have t squared plus 4t minus 21 over t squared plus t minus 12 and then minus 6 over t plus 4. Alright, so to get a common denominator, I got to factor. I had a lot of people that factored the numerator, and you could do that, but I'm not going to do it yet because I'm going to want to subtract on the top first. Okay, so on the bottom here, factors of negative 12 that add to 1, that's the same as t plus 4 times t minus 3. So my common denominator's got to have a t plus 4 in it. It's got to have a t minus 3 in it. Over here with the 6, it's got a t plus 4. I already got that covered. So that's going to be my common denominator. Okay, this piece up here on the top left, did I change it in any way? Did I multiply it or divide it by anything? No, I just wrote it in a different form so I don't have to change the top. But here with the 6, it only had a t plus 4. I multiplied the denominator by t minus 3. So I got to multiply the numerator by t minus 3 also. And this is why I didn't want to factor the top left yet, because after I distribute that 6, I can subtract like terms. Okay? So that'll make 6t minus 18. So I got t squared, then I got 4t minus 6t, and I got negative 21 minus negative 18. Now this is the question that everybody always asks, how do I know if I need to go farther on that or not? If I can factor that top and it has one of these pieces from the bottom that I can ninja, then I need to. So that on the top the factors of negative 3 that add to negative 2 are negative 3 and 1. So now you see you've got a t minus 3 on top and bottom. So all that's left is t plus 1 over t plus 4. Yep. Yep. Is that good?
I have a question.
Okay.
Is that 6t minus 3 up there?
6 times t minus 3? Yeah.
Why is it t minus 3?
Because it already just had a t plus 4 on bottom, and the new thing we multiplied by was t minus 3. So we had to do that on the top also.
Okay.
Alright, let's see if anybody else needed the bottom for another second. Alright, we got what we need there? Almost? Okay, you're fine. On 11, it's division. So the question is, when it's division, do you need a common denominator? I only heard one person that knew. No, you don't. So you don't have to worry about common denominator or multiply and divide when it's like this. All you want to do is factor everything to see what you can ninja out. So every one of these trinomials on this thing can factor. If I can write them all correct. Minus x minus 12. Okay, so top left. Factors a negative 35 that add a negative 2. That's negative 7 and positive 5. Bottom left. Factors a negative 21 that add a negative 4. That's negative 7 and positive 3. Top right. Factors of 20 that add to 9. That's 4 and 5. Bottom right. Factors of negative 12 that add a negative 1. That's negative 4 and positive 3. Don't ninja anything out from there, because it's got to be top and bottom, and this is a division problem. So when it's a division problem, we got to take the reciprocal. So on left's going to stay the same. Some of y'all change that at the first, and that's good if you do it at the first. I'm going to keep the left the same. This is now multiply, and we'll take the reciprocal over here. Alright, so you're looking, and it can be diagonal as long as it's on top and bottom. So obvious here, I got a 5 and on top, and bottom, I got a 3, so all that was left is x minus 4 over x plus 4. Okay, 12 is multiply. So do you need a common denominator to multiply? No. So that's good. You haven't got to flip it on multiply. Everybody ready? Alright, 12 I had p squared over p plus 6 times p squared plus 11p plus 30 over p squared plus 6p. Alright, so this right side, nothing can factor over there. P squared, p plus 6. That's just going to stay, so I'm just going to write it again. Times, top right. A times c is 30. Factors of 30 that add to 11. 5 and 6. Okay, bottom right. P squared plus 6p will factor. What do you do to factor that? Take a p out. Very good. Has a GCF. That leaves you with p plus 6. Okay. Now, when people got here, they wanted to mark out all the p plus 6's. You can't do that. You can only mark out a 1 to 1. So you got 1 on top, you can mark 1 out on bottom. You don't have another one on top to mark this one out. So you still have to have a p plus 6 on bottom. Okay, but you can reduce those p's. P squared over p is just p. So on the top I got p times p plus 5. And on the bottom I got p plus 6. If you distributed that p on the top, you could. That p squared plus 5p would be okay. I just saved myself some work and left it like that.
So if you didn't factor the bottom.
Alright, we ready for 13? They good? Alright, 13 is just monomials, so again that's like number 9 and like the bell ringer, except we don't have to flip it, it's multiply. Does that say 7m squared? I've scratched all over mine.
Yes.
7m squared, what's the 3 into? 3 into the 5th. I scribbled on mine when I was working. 8n to the 6th and 10m to the 4th. Is that all right? Okay. I'm going to work this, though, like y'all would. On my paper, I marked out individual pieces like I did the bell ringer, but I'll work this like y'all would. Straight across the top, 7 times 8 is 56. M squared times n to the 6th just stays like that. 3 times 10 is 30. N to the 5th, m to the 4th. All right, 56 over 30. All you can do on that is reduce that, take a 2 out of both of them. It ends up being 28 over 15. Bless you. Now I got m squared and m to the 4th. So what does that leave me with on the m's?
N squared on the bottom.
Good. Then I got n to the 6th and n to the 5th.
N on the bottom.
Very good. That's it. Divided it by 2, reduce 56 over 30. All right, on 14, it's addition. So what do we got to worry about on addition? Common denominator. Everybody ready? Okay. I've got 4 over m plus 8 plus 1 over m squared minus 64. So when I need a common denominator, if there's something that can be factored, I need to factor it to see what it's already got. How does m squared minus 64 factor? Very good, Macy. So it's m plus 8, m minus 8. So looking, the 4's got an m plus 8, the 1's got an m plus 8, m minus 8. What's your common denominator going to be? And it's going to have an m plus 8. What else? An m minus 8. It's got to be the product of them. Okay, so the 4 already had the m plus 8. The new thing we multiplied its denominator by was m minus 8, so we got to do that on top. The 1 already had them both, so we don't have to change it. Okay, so what we're looking at here, I got 4m minus 32 plus 1 over m plus 8, m minus 8. And now I know what negative 32 plus 1 is. Okay, I left my answer there. If you went ahead and wrote m squared minus 64 on bottom, that's correct too. You could write it either way. I know 31's prime, so I'm not going to be able to factor that and ninja anything else. So. For Valentine's Day, chocolate stores producing chocolate-covered strawberries in the shape of a heart. We ready? We got to write the equation as I read it, so I got what you need here. All right, it says the initial cost for the store to produce the item was $560. Get out of the way. $560, so that's going to be on top of whatever, so we're going to have to add that to. The store estimates that it'll cost 84 cents to make one heart-shaped chocolate strawberry. So 84 cents for one of them, so if we're going to make a bunch of them, be 84 cents times however many we make, right? How many of these do they need to make before the average cost for each is $1.25? So cost for how many of them is $1.25. Okay, comes just a simple little middle school equation. Subtract your 0.84x. And I mean 560. I didn't write all my steps down. What do you get? 141?
Yeah, I got
0.41, then divide by 0.41. And I got about 1,365.8. Read the directions. The problem says round to the nearest whole number. So that would round that up to 1,366. They had to make 1,366 of them before you could make $1.25 off of them. Yeah, but Valentine's Day, candy and flower businesses, they do the business, so. All right, 17, back page. 16, excuse me, 16. Are you ready? It says the length S in inches of a cello string varies inversely as the frequency. So S varies inversely as the frequency. I don't know why they used S for length, but they did. So that would be how we're starting off there. A cello string that is 6 inches long, so 6 goes in my S spot, vibrates at a frequency of 600 cycles per second. So my A is being divided by 600, so I'll multiply by 600, and my A is 3,600. Okay, then it says find the frequency at which a 9-inch string vibrates. 9 inch is the S. So 9 would equal 3,600 divided by F. Trying to solve for F. You could go about this a couple different ways. You know, this is the same as 9 over 1. So I just looked at it that way. 9F would equal